Good day, everyone. So for today's discussion, we're going to discuss about the slope of a line. So for our target learning objectives for the day is we have to illustrate and find the slope of a line given 2 points equation in the graph. So for today's discussion, we're going to have defining the slope of a line, finding the slope of a line given 2 points on the line, and we have to find the slope of a line from a table. So first, let us define the slope of a line. So when we say slope, so the slope of a line, when we say slope, so the slope is equal to the vertical change over the horizontal change, or it is equal to the rise over run. Wherein when we say rise, this is the change in y, okay? And when we say run, this is the change in x. So remember that the slope of any non-vertical straight line containing the slope or containing the points with coordinates x sub 1 and y sub 1 and x sub 2, y sub 2 is defined by the formula m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x sub 2 should not be equal to x sub 1. Why is that so? Because when x sub 2 will be equal to x sub 1, your denominator will be equal to 0. And if that happens, okay, and if that happens, your fraction will always will be equal to 0. And if that's the case, if the denominator is equal to 0, that is the time that your fraction will be and always be undefined. So therefore x sub 2 should not be equal to x sub 1. So again, we have here the formula m is equal to y sub 2 minus y sub 1, where over x sub 2 minus x sub 1. And then we're gonna move forward with finding the slope of a line given 2 points on the line. So how are we gonna solve this one? So we're going to use this formula. We're going to use m is equal to y sub 2 minus y sub 1 over x sub 2 minus y sub 1. So this is the formula that we're going to use to find the slope of a line given 2 points. Okay, so again, that is the formula that we're going to use if we were talking about the slope of a line given 2 points. Okay, so first, let's have our example number 1. So we have find the slope of a line that passes through 4, 5, and 2, 1. So first, let 4, 5, okay, let 4, 5 be x sub 1 and y sub 1, and 2, 1 be x sub 2 and y sub 2. So let's write the formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So after this, we're going to substitute the value. So y sub 2, that would be 1, minus y sub 1, that would be equal to 5, over x sub 2, that would be equal to 2, minus x sub 1, that would be equal to 4. And then simplify. 1 minus 5, that would be equal to negative 4. 2 minus 4, that would be equal to negative 2. So when we simplify negative 4 over negative 2, that would be equal to positive 2. Okay, so what about, or what will happen if we let 2, 1 be x sub 1 and y sub 1, and 4, 5 be x sub 2, y sub 2. So let's try. So we're gonna use the other way around. So we have y is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we're gonna interchange the value. So we have 5 minus 1 over 4 minus 2. So 5 minus 1, that will be equal to 4, and 4 minus 2, that would be equal to 2. 4 over 2, that is still equal to 2. So clearly, it does not matter which point is called x sub 1 and y sub 1, and which is called x sub 2 and y sub 2. So let's try to graph this one. So we have 4, 5. Let's locate where is 4, 5. 4, 5 is somewhere here because 4, positive 4, and positive 5. So that would be 4, 5, and then we're gonna locate 2, 1. 2, 1, it's here. So we have 2, 1, and then we're gonna connect this point. All right, so let's assume again that this is a perfect straight line. So we have the run, which is 2. So let's try to draw broken lines over here to see the rise and the run. So we have 1, 2. This would be your run. Okay, this would be your run. That is 2 units. And then your rise, that would be 1, 2, 3, 4. So your run is equal to, your rise is equal to 4. So again, rise over run. So that would be 4 over 2. So 4 over 2, that would be equal to positive 2. Therefore, the slope is equal to 2. So note that a line whose slope is 2 moves 2 unit upward with every unit to the right. So let's look. So when you move 1 unit to the right, so there you have 1, 2. And then you move 1 unit another to the right, you have 1. It moves 2 units upward with every unit to the right. Alright? So, let's have our example number 2. So, we have to find the slope of a line through -3, 4, and 1, -2. So, let x sub 1 and y sub 1, -3 and 4, and then x sub 2, y sub 2 is 1 and -2. So let's just substitute the given to the formula again. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have -2 minus 4 over 1 minus -3. So -2 minus 4, that would be equal to -6 over 4, because that's the operation, and thus the sign will be changed. So that would be equal to 4. So 1 plus 3 is equal to 4. So you have -6 over 4, and that would be equal to -3 halves. Okay, so the slope of the line is negative. So how are we going to graph this one? So first we locate -3, 4, -3, positive 4, -3, positive 4, it's somewhere here. And we have 1, -2, 1, -2, so it's somewhere here. So let's connect the points. All right, so there you are. So let's see. Note that for every 3 units move up, the line moves 2 units to the left. So let's use another color of pen so that it would be easier for you to identify how is the moving goes. So we have, let's start with 1, -2. So we move 2 units to the left. So 1, 2, and then up 1, 2, 3. So that's the first movement. And then the second one would be 1, 2, 1, 2, 3. All right. So that is how the movement goes. So 3, -2, 3, -2. Okay. So this is how a negative slope is graphed. All right. So next, let's move with example number 3. So we have to find the slope of a line through -2, 2, and 3, positive 2. So let's just substitute the given in the formula. So we have m is equal to 2 minus 2 over 3 minus -2. So we have 2 minus 2, that would be equal to 0 over 3 plus 2. Alright, 3 plus 2, that would be equal to 5. So 0 over 5, that would be equal to 0. So the slope of the horizontal line is 0. So let's see if the graph of this one will be horizontal line. So first, let's locate negative 2, 2. So negative 2, 2, it's somewhere here, and 3, 2. Alright, so 3, 2, it is 3, 2, it is located here. So when we connect the points, so we come up with a horizontal line. So remember that the slope of a horizontal line will always be 0. So let me write this one. The slope of a horizontal line is 0. Okay, so take note of that. So let's proceed with example number 4. So we have to find the slope of a line that passed through 2, -1, and 2, 3. So let's just substitute our values again. So we have m is equal to 3 minus -1 over 2 minus 2. Okay, so we have 3 plus 1. So because again, this will be changed. So 3 plus 1, that would be 4 over 0. So 4 over 0. So let's see if when we graph it, there will be slope. So we have 2, -1, 2, -1, and 2, +3. So we come up with a vertical line. Okay, with the vertical line. So remember that the slope of a vertical line, the slope of a vertical line, okay, of a vertical line is undefined, is undefined. Okay, remember that the slope of a vertical line is undefined since division is 0, is not defined. Okay, so it is clearly seen by here that the slope of these numbers or the slope of these ordered pairs will be undefined because the denominator is equal to 0. Alright? Okay, so next. Okay, so the last part would be finding the slope of a line from a table. Okay, so finding the slope of a line from a table. So the table below shows coordinate of the points that lie, okay, on the same line. So determine the points of the line. So we have to graph and identify the given points. So first, let us graph this point. So we have first 5, -4, 5, okay, 5, -4, it is here, 3, -1, 3, -1, 1, +2, and then -1, -1 and 5, and then lastly is -3 and 8. So it's somewhere here. Okay, so when we connect the points, okay, so again, there you are. So let's assume again that this is a very perfect straight line. Alright, so let's see how is the changes in x and y does. So first, let's have the change in x. So 5, 3, how it will become 3. So coming from 5, you have 2 less 2. So minus 2. 3 to 1, that is minus 2 again. 1 to -1, that is minus 2 again. And then -1 to -3, that is minus 2 again. So we can clearly say that the change is x is 2 or -2. And then we have 4 to -1, that is plus 3. 2, -1 to 2, that is plus 3 again. 2 to 5, that is another plus 3. And then 5 to 8, that is another plus 3. So coming from this, so again, the slope is equal to change in y over the change in x. Change in x. Alright, so change in y, that is equal to 3 over the change in x, that is equal to -2 or 3 over 2. So let's see how it goes in our graph. So we have 3. So that is 3. 1, 2, 3. So 1, 2, 3, and then 1, 2. So that is the first one. So next, 1, 2, 3. So we still have 1, 2. Alright, and then next, 1, 2, 3, then 1, 2. Just disregard this one, and then 1, 2, 3, 1, 2. Okay, So this is how, okay, so this is how, my apologies for this. So that is how the graph of these points looks like. So let me do the graph. There you are. All right, so that is how the graph of these points looks like, and the slope is 3 2 or 3 over negative 2 or negative 3 halves. All right, so that will be all for this day. So thank you so much, everyone.